When people think of the artificial intelligence industry, they tend to picture invisible algorithms and endless lines of code floating in the cloud. But training a new frontier AI model requires a massive footprint of heavy metal, concrete, and industrial-scale electricity. Inside a data center, you will find endless rows of server racks stacked to the ceiling. Tens of thousands of these units run simultaneously, drawing enough power for a small city. Every request routes through millions of microchips humming inside those racks. Physical supply chains currently set the absolute speed limit for machine intelligence. Right now, that massive global supply chain narrows down to a single fragile bottleneck. Almost every major AI lab, from OpenAI to Meta, is entirely dependent on NVIDIA. Their specialized processing hardware is the mandatory baseline for training top-tier models. Because everyone is fighting over the exact same supply pool, hardware costs have skyrocketed. Waitlists stretch for months, forcing fierce bidding wars just to secure enough infrastructure. Total reliance on a single physical vendor transforms a brilliant software business model into a massive existential vulnerability. To escape this chokehold, some labs are actively restructuring how they source their physical infrastructure. The most telling example is a recent maneuver by Anthropic. Instead of waiting in line for the established standard, Anthropic quietly began purchasing AI chips directly from an emerging UK-based startup. They bypassed the dominant supplier entirely. The immediate logistical benefit is obvious. By sourcing alternate hardware, Anthropic secures the compute it needs without having to outbid its larger competitors or endure brutal production delays. This maneuver functions as a calculated geopolitical hedge against a looming, tighter global supply crunch. Securing a backup supply is only the first step. The deeper value of acquiring alternative hardware is the ability to rebuild internal architecture. Standardized components force software to fit rigid hardware boundaries, but with independent chip makers, labs customize physical data pathways for their proprietary models. This vertical integration removes external manufacturing friction, letting teams iterate and deploy on their own schedule. Stepping outside the established monopoly gives an artificial intelligence lab absolute, uninterrupted control over its own evolutionary speed and future development. The primary rule of the modern artificial intelligence race is simple. Whoever controls the physical compute controls the timeline. This introduces the concept of hardware sovereignty. Long-term corporate survival now requires a company to own or directly control the physical components that run its code. Silicon Valley firms that spent decades ignoring the physical world are rapidly hiring hardware logistics experts to secure factory output. The chip wars are currently an active, invisible struggle unfolding behind the closed doors of every major tech lab. The eventual winner of this race will win by building the most independent, unbreakable physical supply chain.